impressive presentation. With the language, that's great, and very great details for your theories and clear demonstration, especially you can explain clearly about what is flying turtle and what is the castleware, something like that. That's great. Okay. Then we have some suggestions for you, other questions. First, we would like to maybe you should more clearly understand the relationship between the two kinds of force, the relationship, and then you can do more credible data, I think, because human being is difficult to control the flying turtle and heuristics. There are too many variables to control, and I think probably you can think about the problems in a way of energy, because I think it's more easy to understand in a macro way. And more is maybe you can do some application of words, not just study how they work, because just studying how it works maybe in a wrong direction. That could be a little bit embarrassing. So I suggest you can do more applications on the board. And now I begin to ask my question again. First, I believe that in USAYPT, that in these problems we need to do some video experiments, but I didn't see any videos in your presentation.
It just said that many of you guys will use video experimentation. We didn't feel that it was necessary. We did try using video experimentation, but the only thing that we could glean from the video experimentation was an analysis of the angular acceleration and the sinusoidal path, both of which we felt were not applicable to how it causes and maintains motion, which is what the problem statement was. It did not require us to use video motion. And we didn't need video because we had a different form of collecting data.
How do you define the necessary? Why is it not necessary? Because radio can make it out clear visuals to see the problem and how it works.
We use graphs in order to clarify the problem, and our model was that kinetic friction is the cause, and so we felt the best way to test this is by testing different surfaces and different frictional surfaces, as opposed to making just a model and using a video motion analysis for the paper. And we also
you just say that you do your math models, your basic math model, but no videos. But how do you connect the reality to the theory? Your theories, it's a model. Model cannot to support your anything.
So we had our model, which was that the lateral kinetical friction force is what causes the motion, and we conducted two experiments to verify this. First was the relocation of the axis, and second of all was the testing on different frictional surfaces in order to prove this. Furthermore, yeah?
Oh, okay, just follow your answers. What about the data of the second experiment? Maybe I just didn't see your data in your second experiment.
Are you talking about the one for? Are you talking about the one for the relocation of the axis experiment, or are you talking about the flying turtle or the heuristic? Sorry. Here.
So what's this is the experiment one.
Right? This is our experiment, or it's experiment 2. For the first experiment, yes, for the first experiment we don't have numbers because the turtle.
What's your purpose for the first experiment?
Could you just repeat what you have made?
What's your purpose for the first experiment?
It's to verify that the lateral kinetical friction force is the root cause of motion by testing different various frictional surfaces with greater mu values and seeing if that corresponds to the time it takes to traverse a given distance of 6.1 meters while keeping the force constant using force sensors.
Okay, what about your data in here? You can see that you made this second, but how you just take the time taken, right?
Time taken to travel 6.10 meters while applying a constant force.
Don't you think because it's a robot riding your flying turtle and heuristic?
Are you robots?
Or just humans riding your flying turtle and heuristic?
Humans, I rode the flying turtle and I used force sensors and I practiced for several months to make sure that I would be able to pull with a constant force. And
how do you control another variables?
I attached force sensors to both of the handles and I had logger per running in order to make sure that my force was within 10% of each other, the peak force that I pulled with. That is on either end, the peak force that I pulled with, because it's like a graph like this.
Oh, what about your frequencies to wiggle your body?
Oh yeah, we use a stopwatch to verify that.
You use you just in your feeling to control your frequency and your force.
We use the stopwatch to control the frequency and force sensors to control the force.
sensor.
Yes, we
Can
attach
you show us the sensors, how you control the force?
So there are these sensors like by Water Pro that you can get, and you just hook them up. As you can see, the duct tape is still on here. And we pull on the sensor, and it measures the amount of force you pull with, and you get a graph. And we make sure that the peaks and the lows of our graph are within 10%, and in order to make sure that our experiments were done.
Okay, let's pass to another question. What about you just say that we can apply the same theories on both polarized, and I agree with that, but why? Can you explain this?
So basically, what happens is both as shown by our two different experiments, both of these vehicles are moved because of a lateral kinetic friction force. The only difference is what causes that reactionary force. In the case of the turtle, it's pulling on it, and in the case of the ripstick, it's pushing on it in 3 dimensions. Versus this one moves in 2 dimensions. But all that is different is like the forces that you pull on it with, and the dimensions in which you can move it in.
So you believe the only difference is the direction you push you give the force?
Yes, they both have. In fact, because of the way we conducted our experiments, we made it so that the ripstick only had 1 caster wheel, because even though the ripstick has 2 caster wheels, by not moving the front deck, even though we could have, it made sure that the only 1 caster wheel is effectively moving in order to simplify the experimentation. 2 caster wheels would just double the effect, as evidenced by the math model.
But actually, we can clearly see that the flying turtle and a ripstick have a totally different structure of the caster wheel. I think we cannot just simply say that caster wheel. Caster wheel, different kind of caster wheels.
Yeah.
You didn't analyze the structure.
I did. I have 2 separate free body diagrams and 2 separate that illustrate the differences in the wheels. I'm saying both of them have caster wheels, and as a result, the claim I'm making is that they're both similar, that they're both propelled by a lateral kinetical friction force. I'm not saying they're both the same object. They look very different. I agree.
Yeah, but I think this is true. This true for I just said painting is 2 dimensions, but actually we are analyzing the 3 dimensions.
Yes, that has 3 dimensions. There's a z-axis, a y-axis, and an x-axis.
Can you point out the driving force, the direction of the driving force? Direction.
Oh, it's in the positive. I'm looking at the motion in this case in the positive x direction, and in this case in the positive y direction, because this is the way I've oriented the diagrams.
Where is the driving force?
Here, it's as a result of this reactionary kinetic friction force. Right now, since the turtle's horizontal, it's not moving, but as you rotate it, this frictional force means a horizontal component and a vertical component that can never be backwards. This supports our observation that it is impossible to move the turtle backwards, and it is also possible to drive the ripstick backwards.
Okay, but here you see, this is the move. We are moving the major direction is forward, right? But here is the kinetic energy. This force has the right angle here. How this force affect the motion?
It is a factor of motion. I have chosen the point of horizontalness to
But
snapshot
here's
this.
the right angle.
Yes, I understand. But when you turn, okay, let me just. Do you mind if I draw a diagram really quickly to explain what I'm trying to talk about?
Okay.
Do you have a Sharpie that put it down? So, when the turn. Sorry, this diagram isn't going to be wonderful. Okay. Alright, so when the turtle is facing this way, we see that the kinetic friction force will be this way. And there will be an x component and a forward y component. Because I've chosen the horizontal component snapshot, you don't see the forward kinetic frictional force. However, anytime there's even any degree of rotation, there is a forward kinetical force. If there was a forward force when it was like this and you were just pulling directly sideways, then that would mean the turtle moves when you're just holding it and pulling sideways.
That's a point of the direction point. What about the ripsticks? Ripsticks here, because we can see that when because when you riding the ripsticks in this way, we can clearly see that there's a high difference.
Yeah.
Well, how can you explain the high difference? Because the flying turtle here, it has no high difference when it's moving.
Yeah, there's a normal force that's exerted, and the height difference is incorporated in the torque exerted by the normal force because we also have the displacement in the z direction, the displacement in the y direction. Or the displacement in the z direction, the displacement in the y direction. And that is included in our torque analysis, where we say that the force, the torque by this force, normal force, times the distance between the perpendicular distance between the caster wheel and the caster wheel and the place where you exert the normal force results in a torque. this is irrelevant which direction it's pointing in, as by saying it's r cross f, that includes the directional aspect in it, because it's a vector. It results in a vector.
Is that highly affected the motion?
Yeah, of course. That's what causes the torque. If you didn't,
Just
if you didn't push
cause the
down,
torque, right?
if you didn't push down on it, then there would be no normal force exerted at an angle. If you push directly in the middle, there would be no torque because you would be exerting a force along the axis of rotation. This means that the torque would be zero.
Okay,
Thus,
well, in this ripsticks, is that also the kinetic frictions?
lateral kinetical friction, I claim, propels both of these vehicles.
Since you don't have any videos to prove that, because can I just assume this just like a bicycle, because bicycle can normally we can know that bicycle is not the kind of friction.
I'm afraid I don't understand. Kinetic friction, by having a video of this moving, that's not going to prove kinetic friction does anything. It's just going to show that the ripstick moves in a certain manner.
I believe that I'm a writer for this too, and when I write these ripsticks, the wheel is rotating, and the touch point from the the center of these wheels, and the touch point is different. I think is just in the experience. I think it shouldn't be kind of confused.
I don't understand how bicycle is relevant, but I'm saying it's lateral kinetic friction. Let me demonstrate, because when you move this wheel, these caster wheels are grinding against the ground because it's moving not in the direction it's rolling, but in a direction perpendicular to the direction it's rolling. Since we know static friction causes rolling, and this is moving, this means it is a result of kinetic friction. I claim that it is a perpendicular lateral kinetical friction force, and it is supported by the experiments that I've conducted. I'm not exactly sure what your question is regarding this.
My question is, I'm confused if it's kind of because it can prove your theory. It's moving.
It's moving, but it's not rolling. It's moving perpendicular to the direction it's rolling. This means it cannot be static friction. Since it is friction, it must be kinetic friction.
Thank you. Thank you very much.